Alright, let's talk about range sum query immutable. So given an integer array nums, handle multiple query of the following type. So you have the class nums array, and then you need to know there's a constructor and initialize the in array, and also the sum range, which takes two arguments, which is left and right. So you have to return the sum of the element of the nums between index left and right inclusive, right? So there is an easy way. So you create an in array, and then you copy the in nums to the in array, and then you traverse using a for loop, and then return the in value. This will take all of them, because for every single time you call some range, right, it takes all of them, right? And there's an easy way to do minimize the time complexity to, on some range to one all of one. So you can use PrevSum. So PrevSum is really important. This is actually like memorize what is the current, what is the previous sum for this current position. So if you just write out on your paper, and then you will be able to know the first index is -2, the second index, which is 1, is -2, and the next one will be -2 plus 3, which is 1, right? 1 plus -5, -4, -4 plus 2, -2, -2 plus -1, which is -3. And this is really important to have the previous sum, and then you will be able to know like what is the time complexity for the sum range. This will only take all of one, right? So let's just traverse. So before you traverse, you need a PrevSum. It's equal to new int, and then stop length plus 1. And then for int, we don't need to know the previous sum at index 0. This is because I will tell you later. So dot length of plus, and PrevSum, right? At I, which is 1, I'm going to add my value, index I minus 1's value plus the nums at I minus 1. So this will actually know like what is the value for list in array, the previous sum for in array. So you have to know like you need extra space for recording the last one. So we're starting from the first index. So we basically like taking every element and then move to the right. The sum of the element, right? And for the sum range, right? Since we only need all of one, right? We just can return what. So to look at this example, so this will become for the previous sum, right? Previous sum, and then I'm going to give you more space of this. So previous sum for the index 0, which is 0, you are not initialized. So -2, -2, comma, -2, comma, 1, comma, -4, comma, -2, comma, -3. So it does take extra space, right, for the previous sum. And when you need to return, imagine you return 0 to 5. When you return, you have to return this index, right? 0 to 5. So what is 0 to 5? The sum of the in array. So this will become -2 plus 3, 1, 1 plus -5, -4 plus 2, -2, -2 plus -1, -3, right? So in this case, you can actually just return -3. But did you actually notice there is the value for -3? So this is now coincident. You need to you need to actually get a value from PrevSum, and then write +1, and then minus PrevSum left. So you don't actually need to +1 or -1 on the left index, because this is actually the PrevSum actually indicate like the value you store in the before this current position. So we can actually test 2 and 5. 2 and 5 is actually 0, 1, 2, 2, 3, 4, 5, right? So this is actually like 3 plus -5, -2 plus 2, 0, -1, right? So -1. So 2 and 5. So I would use right is 5 plus 1 is 6. So -3 minus 2, 0, 1, 2, which is -2. Minus -2 is -1, right? So -3 plus 2 is -1. And this is how it is. So they just run the code and see if I have any typo or not. Yep. Okay, here we go. So for the time and space complexity, so you have to narrow down the sum range time complexity later. But normally the space complexity is all of n, and the time for the sum range is all of 1, which is the best solution. And if you want to know like all of n solution, this is all of n solution. You traverse every single time, you call the sum range, and you return the value. And this is all of n, which is actually more poor in performance on the equation, on the function. So this will be a solution, and if you feel helpful, subscribe, like if you want it, and I'll see you next time. Bye.